Hi everyone, so today we're covering the second half of the notes from 9.5, which we had started on Monday. And then afterwards, there's going to be a second ed puzzle that has just a couple more examples to go through. And then lastly, you'll have your Google form for homework, which will include problems that you're going to check your understanding for what we covered today in class, as well as double check your understanding for what was on the ed puzzle from Wednesday's lesson. Okay, so this first box is just a reminder to you about the Greek letter theta. And remember, that is just what we're going to be using whenever we're talking about the angle. Okay, and theta just meaning that angle can vary, right? In its degrees depending on the length of your base and the length of the height of your right triangle. Okay, when we're going through these examples, the best way to show these relationships is if we make the radius of our right triangle 1. Okay, the hypotenuse that we're using is going to have a length of 1. And the reason for this is because if we use 1, that's the basic number that you can use where you can really see the relationship between your base length and your height. Okay, so what you see here in this image is just looking at only one quadrant of the 4 quadrants in an XY axis. And again, what we're doing is say that we had sketched a whole circle. We're just looking at a quadrant of the circle and talking about each point along the circle. Okay, so if you make any point on a graph, you would reference that point using the coordinates x, y, right? X meaning how did you move left or right? Y meaning how did you move up or down, right? So here we're showing this point xy on the circle, knowing that the radius of the circle is 1, which means that tells us, of course, the hypotenuse for this right triangle is 1. Because remember, we've talked about it a lot at this point. The right angle always points to the hypotenuse. Now, here in this example, our theta is the angle right here, right? And as we know, based off of what your theta is, theta always touches the hypotenuse as well as the adjacent side, right? So this is my adjacent side, which of course, then I can label my y as my opposite side. Okay, really important that we just note that, given that this is theta. Okay, so we've been talking about trig functions for the past couple classes, and at this point we know that if we're talking about sine of theta, what should come into your mind is thinking about SOHCAHTOA, right? And in thinking about SOHCAHTOA, if we're talking about, okay, well then what is sine of theta? Well, sine of theta is opposite over hypotenuse. And referencing back to this unit circle, okay, well my opposite side, if I look at my image, okay, the opposite side is represented by the variable y. So it would be y over my hypotenuse is 1. And then as we know, anything divided by 1 is just whatever's in the numerator. So y over 1 would just be y. So that tells us that interchangeably we can say sine of theta is equal to y. So we can use either sine theta or y, and we'd be talking about the same thing. Okay. And then here, so cosine theta. Well, cosine is the relationship between adjacent over hypotenuse. And again, if we look at our image over here, the adjacent side is x over the hypotenuse, which is 1. Okay. And again, x divided by 1, we can just say is x. So when we're talking about cosine of theta, we can also interchange it just with using the variable x based on the information of this example. Okay. So we've talked about before the Pythagorean Theorem, which is a squared plus b squared is equal to c squared. Now this idea also explains the Pythagorean identity, which is what we're going to get to. Because if we use this logic of a squared plus b squared equals c squared, remember, a and b represent the legs of your triangle, right? So if we look at the legs of my triangle, And again, it doesn't matter which order I put it in. I can state this leg first or this leg first. A squared, I can say, is the same thing. My A is the side of x. I could say is x squared. And then B, I can say my side B is referencing my height. So instead of using B, I can now replace that with Y, because Y represents my height, right? And then C is always the hypotenuse. In this case, the hypotenuse is 1 squared. But just like what we showed previously, we also know that these variables here can be interchanged using sine theta and cosine theta, because we showed that relationship over here, right? Looking over here, cosine of theta is the same thing as x. So we can now replace x with cosine theta, and this is x squared. So that's going to be cosine squared theta plus, and then same thing here, we have y, but as we saw in this previous statement, y can also be interchanged with sine of theta because they're both equal to the same thing. So I can replace y with sine of theta. And because this is y squared, that's going to become sine squared theta. And that's equal to 1 squared. But 1 squared is just 1. And this statement, cosine theta plus sine theta is equal to 1, is what is known as the Pythagorean identity. And that's going to become really important later on in this unit, as well as when you're in pre-calculus and calculus, okay? Understanding where this statement comes from in terms of using it based off of the calculations of a hypotenuse of 1 unit, okay? So now that we have this identity here, we can use that identity to solve for missing side lengths. Okay, so I have the identity cosine squared theta plus sine squared theta is equal to 1. Okay, so here in the example, I'm saying, given that cosine of theta is equal to 3/5, find sine of theta and tan of theta. Okay, the first one that's going to be the most simple to do is going to be finding sine of theta first. Okay, so again, we're going to use that identity that we just came up with over here, and we're just going to go ahead and we're going to plug in the value that was given. So we have cosine squared theta plus sine squared theta is equal to 1. And they gave us in the problem, make cosine theta 3/5. So that means every time I see a cosine, I'm going to replace it with 3/5. Now notice that this is cosine squared theta. So this is going to become 3/5 squared plus sine squared theta is equal to 1. Okay. Now we're going to go ahead and we're just going to do some algebra and solve it out. So 3/5 squared. Well, 3 squared is 9. 5 squared is 25. Plus sine squared theta is equal to 1. So the first thing that we need to do in order to get sine squared by itself is we need to move over this 9/25. So I'm just going to go ahead and subtract 9/25 from both sides. Okay, so I'm going to do 1 take away 9/25. And then just because of space, Well, I'll still do it. Minus 9 over 25 over here. So the 9/25ths cancel each other out. And then on this side, 1 take away 9 over 25. I'm going to just rewrite the 1 as 25 over 25 to make my denominators the same. So 1 is 25 over 25. Take away 9 over 25. And that's going to give me 16 over 25. Okay. So now I have sine squared theta is equal to 16 over 25. Now, of course, the last step, because this is sine squared theta, in order to eliminate that square, we need to take the square root of both sides, meaning that we're taking the square root of this and then the square root of 16 over 25, which is the same thing as saying the square root of 16 over the square root of 25. Okay, so that tells us that those cancel each other out. I'm just now left with sine of theta is equal to, square root of 16 is 4, square root of 25 is 5, and then in the front, I'm going to write plus or minus. Important that you denote the plus or minus, because when we are talking about the unit circle, I know I'm only showing one quadrant of the circle, but if you create the entire circle, of course, depending on what quadrant you're in on your xy plane, so if I would have done the whole entire xy plane, remember that in this quadrant, both of your values are positive, right? Your x and your y. But then say that you go down to this quadrant here. Yes, your x value is still positive, but your y value becomes negative. Okay, and then when you're in this quadrant over here, both of your values become negative. And then in this quadrant over here, your x value is negative while your y value is positive. So it's important to denote the plus or minus, because depending on what quadrant you're in, that's going to tell you whether your value is positive or negative. Okay. All right, so that's sine of theta. Okay. Now we're going to go ahead and we're going to solve for tangent. All right, now keeping in mind that when we're talking about tangent of theta, and I'll just write it off to the side here. Tangent of theta refers to, if we look at SOHCAHTOA, opposite over adjacent, right? So opposite over adjacent. And when we look at our image over here, if we take the opposite side is y, and the adjacent side is x, right? Opposite, y, adjacent side is x. But remember, we're not referencing sides right now based off of their variables. We want to know them in relation to sine and cosine, our trig functions, right? And tangent. So looking back at what we found in the very beginning, y is not just y, it can be interchanged with sine of theta, because those two things are equal, right? So instead of saying y, I can say sine of theta over, and again, going back to what we saw over here, x can also be interchangeable with cosine theta. So instead of writing x, I'm going to write cosine theta. Now, the nice thing is, I know what sine theta is. I already solved for it. I also know what cosine theta is. It was given to me. So I can go ahead and actually plug in those values and then solve for them, right? So looking at this problem, my sine theta, I'm going to solve it just using 4 over 5. So it's going to be 4/5 over my cosine theta is 3/5. Okay. And then I can go ahead and actually solve this, right? 4/5 divided by 3/5. So 4/5 divided by 3/5. And remember, when we're dividing fractions, you can always rewrite into a multiplication just by flipping the second term. So that's the same thing as saying 4/5 times 5/3, which is going to give me 4 times 5, which is 20, and then 5 times 3, which is 15. And once I simplify that fraction, that's going to give me 4/5, which is my tangent of theta. And there you have it. We have now solved for sine and tangent when we were given cosine. Okay. So I hope that made sense. Please, if you need to, rewind this video, go through steps, because the second ed puzzle video that you're about to see is going to be a few more examples using this concept where I'm either going to give you cosine or sine, and you're going to be solving for the other two trigonometric functions. Okay.